This is the video homework assignment for Tim Barron for Physics 229, Strength and Elasticity of Materials, and this is problem 1.6-3. We're told in this problem that there's a polyethylene bar that is placed inside a steel tube and that the polyethylene bar is compressed by a force P. And what they want us to do is figure out the force P that will close the space between the polyethylene bar and the steel tube. And the assumptions that we're starting with are that the diameter of the polyethylene bar is 4 inches. The inner diameter of the steel tube is 4.01 inches. The applied compressive axial force is P. The modulus of elasticity is 200 ksi, and Poisson's ratio is 0.4. So what we need to do to solve this problem is we need to calculate the change in diameter, and we are going to use that to determine the lateral strain with the lateral strain formula. And after we find the lateral strain, we can use Poisson's ratio to find the axial strain. And finally, using Hooke's law, we can determine the force that we're looking for, P. So I'm going to go through the solution to this problem step by step. You can see on the screen the first thing we need to do is find the change in diameter, which is just subtracting the second diameter from the first diameter, which leaves us with 0.01 inches. And then we are going to find the lateral strain by using that change in diameter over diameter 1. We've got 0.01 over 4, which gives us 2.5 times 10 to the minus 3. And then we're going to be able to plug that in to Poisson's ratio. Since we were already given the value for Poisson's ratio, if we rearrange that a little bit, you'll see that we can find the axial strain by putting the lateral strain over Poisson's ratio, which is going to leave us with negative 6.25 times 10 to the minus third. And once we have that value, we can use that in Hooke's law in combination with the axial strain formula. As you can see, that we can combine those two formulas together since they both equal the same thing. So we'll get P over the area is equal to the modulus of elasticity times the axial strain, and rearrange that a little bit to get P by itself, and we'll get P is equal to 200 times 6.25 times 10 to the minus third times the area, which is pi r squared, so pi times 4 in this case, and the final answer will be negative 15.708 kips. As you can see, with the given information, we were able to solve for the force needed to close the space between the bar and the tube. Obviously, being familiar with the stress-strain formulas, Hooke's law, and Poisson's ratio will greatly aid in solving problems of this nature.